You're probably familiar with these radio sets. They're part of the ANGRC 3 through 8 series. You might say they're members of the same family. They're all similar, but not identical. The chief difference between them is their frequency ranges. For example, the RT66 covers the range from approximately 20 to 28 megacycles. The RT67 from 27 to 39 megacycles. And the RT68 from 38 to 55 megacycles. Ordinarily, you wouldn't find an installation that included all of these units. But if you'll follow the demonstrator over to the blackboard, he'll show you why they are stacked in one pile. Let us assume that this line represents a frequency range of from 20 to 55 megacycles. Within this range, the ANGRC 3 through 8 equipment can provide 350 channels. But there's one problem. The series covers this band, but it cannot be covered by any single transceiver in the series. For example, the RT66 covers approximately this much of the spectrum. The RT67, the middle range. The RT68, the upper range. To utilize the full range, all three transceivers must be used. Add their mounting bases, power supplies, and interconnecting cables, and you would have this much equipment. What you're looking at now is receiver transmitter RT246, which replaces the old equipment and provides additional channels. This is just one component of the VRC12 family. The VRC12 family of equipment includes the receiver transmitter RT246, the receiver transmitter RT524, and the auxiliary receiver R442. How much of a job can these radios do? Before we answer that question, let's discuss the subject of nomenclatures. These three sets are the basic units. Specific combinations of these three basic units make up the ANVRC12 and the ANVRC 43 through 49 systems. The identification ANVRC12 refers to a combination of the automatic transceiver RT246 with the auxiliary receiver R442. The automatic transceiver alone is called the ANVRC 43. Used with two auxiliary receivers, it becomes the ANVRC 44. Two transceivers together are called the ANVRC 45. The manual transceiver RT524 alone is called the ANVRC 46. The 47, the 48, and the 49. This chart sums up the 8 possible configurations of the ANVRC12 family. Now let's get back to the subject of performance. Note that the ANGRC 3 through 8 family covers a range of 35 megacycles. This range of 46 megacycles results in an increase in range of 11 megacycles. The channel width has been reduced to 50 kc, and the former 350 channels has been increased to 920 channels. Each basic radio covers the full 30 to 76 megacycle spectrum. Every single radio, transceiver, or receiver is usable over the entire 920 channels. This capability is most advantageous. Another limitation of the ANGRC 3 through 8 family is the absence of complete overlap of frequencies between armor in the lower range of frequencies, artillery in the middle range, and infantry in the upper range. Armor can communicate with artillery within this limited overlap. Infantry can communicate with artillery within this limited overlap. But without additional equipment, there cannot be direct communication between armor and infantry. With the ANVRC-12 family, there is no such limitation. Any unit with a VRC-12 can have complete communication with any other unit having a VRC-12. Now, let's make other comparisons. In the ANGRC 3 through 8 series, each set weighs 215 pounds. And each set occupies approximately 2.5 cubic feet. The ANVRC-12, by comparison, weighs only 100 pounds and occupies only 1.2 cubic feet. In other words, it is lighter and smaller. GRC 3 through 8 family has a power output of from 15 to 20 watts, providing a range of about 15 miles. The ANVRC-12 has a power output of 35 to 40 watts with a maximum reliable range of 25 to 30 miles. You can see then that the ANVRC-12 family increases both distance and power output. It extends frequency range and number of channels. It reduces weight and size. It provides complete overlap of communications. It reduces the number of components required, and as we will later demonstrate, maintenance has been simplified. With the basic units of the ANVRC-12 family, many components can be made accessible within a matter of seconds. Much of the quality that has been built into these units is visible to the naked eye. For example, the utilization of space. This is a solid package with a multitude of parts packed into a minimum of space. Heat-producing components have been grouped in one section, where the chassis itself functions as a heat sink and where ventilation has been provided. Let's assume a technician suspects a defect in the transmitter modulator assembly. By unscrewing two captive screws, the transmitter modulator assembly can be made accessible for troubleshooting. Note again the compactness of the set. For better demonstration and safety, there is no power connected to this set. To permit maintenance tests with the set in operation, this assembly is hinged and can remain in a vertical position. This bottom plate separates the components of the transmitter modulator assembly from the assembly below. Note that it has labeled test points. It is held in place by simple-to-operate sliding locks. When it is necessary to disconnect any wires, their color coding, varying lengths, and identifying number assure correct replacement. In an emergency, when there is no time to pinpoint the trouble by module, the repairman could replace the entire assembly with this spare. If time does permit, module substitution can be used. Within each module is a variety of miniature components, including transistors. The modules are mechanically connected to a printed circuit board, which provides electrical interconnection. The suspected module, which is identified by number and function, can be removed by loosening one screw, which serves as both a mechanical lock and a ground, and unplugging it from the board. A replacement module can be installed with equal ease and speed. The ANVRC-12 contains over 100 transistors and only 8 vacuum tubes. In practical terms, these plug-in modules mean subassembly and assembly interchangeability, go-no-go testing, easy component substitution, and less complex training of maintenance personnel. In fact, we've just watched a technician replace a circuit in a matter of minutes with nothing more than a screwdriver. These sets can be installed in a great variety of military vehicles. The installation kit includes individual hardware, antenna mounts, control boxes, audio accessories, and brackets for mounting the basic components. Let's look at a VRC-12 installed in a M151 Jeep. The antenna is a center-fed half-wave device. This antenna matching unit selects the proper loading network, which supplies the transceiver with the correct resistive load and provides optimum performance under a great variety of circumstances. Power is supplied from the vehicle's battery through this cable and into this plug. This receptacle makes contact with the plug in the mount. The set is held in place by these mounting clamps. This cable connects the antenna to the set. This control cable connects the antenna matching unit to the control circuit. There are 4 other receptacles on the front panel. The retransmit RW mic receptacle is for retransmission with certain other types of radio sets and for connecting a microphone. This receptacle is used for attaching the speaker. This remote receptacle is for connecting the remote frequency control box C2742. The X-mode receptacle makes it possible to relay wideband information, such as facsimile messages. The receiver's front panel controls are duplicated on the transceiver. Let's follow the operator as he prepares the set for operation. The power switch has 4 positions, including off. When switched to low, the receiver power is on and the transmitter can operate at low power. When switched to high, the receiver power is on and the transmitter can operate on high power. The remote position allows power for both the receiver and transmitter to be controlled remotely. This lamp functions as a power pilot light and also serves to illuminate the tuning dial. This light switch turns the lamp and call light off for blackout operation. When both the light switch and the power switch are in the on position, both lamps have power. The A position of the band switch covers the range from 30 through 52 megacycles. The B position covers the range from 53 through 75 megacycles. The auto position allows the tuning to be controlled by the push buttons. The AN-VRC-12 has a new tone-operated squelch circuit. The purpose of the squelch is to deactivate the speaker during periods of no signal and to activate the speaker at the receiving station when transmitting. It is strictly an on-off device and can be explained as follows. The audio frequency spectrum extends from 20 to 20,000 cycles. Of this range, the AN-VRC-12 uses the frequencies from 500 cycles to 3,000 cycles. This is the range used by the AN-VRC-12 for voice communication. The AN-VRC-12 squelch circuit creates a tone of 150 cycles, which falls well below the range of audio frequencies needed for voice operation. Let's demonstrate. The 150-cycle squelch tone is transmitted when the microphone switch is depressed. When the tone is received, the receiver squelch circuit will automatically be opened and the call lamp will light. Notice that you do not hear the squelch tone. It is filtered out and is not heard on the speaker. Yet the receiver is still open, available to receive any message. Here's one now.
Acorn 2, Acorn 2.
When the microphone switch is released, the rushing noise is squelched and the speaker is silent. Thus, the 150-cycle squelch tone is only necessary to open or close the squelch circuit, which in turn activates or deactivates the speaker. The 2 upper positions of the knob affect the new squelch system we've just seen in operation. It's a simple control. It's either on or off. The 2 lower positions provide on-off control for a noise-operated squelch system, the system now in use. This makes the AN-VRC-12 compatible with the AN-GRC 3 through 8 radio sets. The volume control, as with present sets, adjusts the audio output level of the speaker or headphone. Manual tuning is accomplished with these 2 knobs in conjunction with the band switch knob. The left-hand knob tunes in 1 megacycle increments. The right-hand knob tunes in 50 kilocycle increments. Thus, manual tuning of a particular frequency involves, at maximum, the operation of 3 knobs. Let's set up a frequency to demonstrate. First, the band switch is set for the desired band. Second, the megacycle tuning knob is set at the desired position. Finally, the kilocycle tuning knob is set at the desired position. With very little practical experience, an operator can manually tune these transceivers and receivers quickly and easily. To utilize the push-button tuning feature, the operator turns the band switch to the auto position. There are 10 preset channels, each available at the push of a button. This almost instantaneous selection of channels represents a maximum of speed and efficiency. Presetting the 10 channels can be done very easily and quickly. 2 captive screws are loosened and the presetting controls are made accessible. Instructions for presetting are printed on the reverse side of the plate. The preset controls are vertically aligned with each button. To preset channel 1, set this screw head switch to the band that includes the desired frequency. Then press the channel button. Holding the button marked Tune depressed, he turns the remaining screw head until the desired frequency appears on the tuning dial. When the desired frequency is reached, the Tune button can be released. Once this presetting operation has been performed, returning to a particular frequency is simply a matter of pressing the desired button. Write-in spaces are provided above each button to record the preset frequencies. All 10 channels can be preset in a matter of a few moments, and when preset, the result is an almost instantaneous selection of any one of 10 frequencies. A remote frequency selector permits control of the VRC-12 from a remote position. This switch on the side gives the operator control of the radio set. The light tells him when he has control. This switch enables him to select low or high power and turn the radio off or on. With this switch, he can select any one of the 10 preset channels. It's a handy device, and it adds to the flexibility of the AN VRC-12. This is only one of a complete line of accessories that are available. Let's give them a quick once-over. They include the AM1780, which is an audio interphone amplifier. It provides interphone and control facilities for different installations. Operating controls, indicators, and connectors are mounted externally. There are a variety of small, compact control boxes that adapt the radio and the interphone sets to their environment. There are new headsets and new dynamic microphones and handset. This equipment allows remote control operation of the AN-VRC-12 family up to approximately 3 kilometers. One unit stays at the radio position, while the other unit is utilized at the remote position. The connection is made with telephone wire. These items, combined with the features built into the radio sets, offer a combat area commander a communications system that provides complete flexibility and adaptability. Modern warfare can demand that these forces be scattered over a wide area, but their movements must be closely coordinated. The AN-VRC-12 and its associated sets and accessories will provide the commander with a reliable means of achieving and maintaining that coordination. 920 channels can accommodate many networks, and any transceiver will be able to talk to any station in any network. Units whose frequencies have been preset are no further away than the push of a button. Let's review some of the important features of the AN-VRC-12 family. They are light, small, and compact. Power output is 35 to 40 watts. Range is 25 to 30 miles. Their frequency range is from 30 to 76 megacycles. Each set has 920 channels with a channel every 50 kilocycles. They utilize a new antenna, an improved squelch, automatic tuning, and a full line of accessories for varied installations. They will be easier to install, operate, and maintain. Specific combinations of the three basic components satisfy a wide variety of communication needs. The ANVRC-12 family of equipment provides the range and flexibility of communication required to maneuver a variety of striking forces in modern warfare.